This is part 2 of my do-it-yourself 3D printed, scale Bally Fathom pinball machine. In this video I show how the lamps and sensors are made and how they are inserted into the playfield as well as the painting work. The lamp consists of a lamp body and an LED. The LED is soldered to wires and insulated with shrink tubing. The LED is checked. A shrink tube is then placed over both wires. The LED is glued into the body with a light-activated glue. After the first fixing, the hole in which the LED was inserted is filled with glue and hardened. It takes a lot of time to make all the lamps needed. Making a sensor is similar to making a lamp. The sensor consists of the sensor body, a coil, a control 3mm LED and optionally a 5mm LED which takes on the lamp function. I always use a yellow and green connecting wire for the coil and a 0.1mm diameter enameled wire for the coil. The yellow connecting wire is soldered to the enameled wire. The connecting wire is then glued to the body. For this type of sensor, I wrap the enameled wire around the body 30 times. The enameled wire is secured to the body with glue and then soldered to the green connecting wire. Afterward, the connecting wire is also glued to the body. The enameled wire is now glued all around to the body. Before the next steps, the coil must be checked. To do this, the impedance is measured with an impedance meter. If a steel ball is placed on the sensor, the impedance must increase. Now the LEDs for the lamp and the control function are produced and glued into the body. For the lamp LED I always use the colors red and black. For the control LED I always use white and blue. The activities involved are similar to those in the previous chapter. The electronic circuit is designed to light up the control LED as soon as the sensor is activated. This is very useful to check if the sensor is working. It was very difficult to organize orange LEDs. They also have poor luminosity. Therefore, for this large sensor I had to use 4 pieces of LEDs connected in series. To test the sensor with the associated printed circuit board, a DuPont connector is crimped to the wires. Here the circuit is adjusted and the sensor is tested. The rightmost yellow LED indicates an active sensor. Under the link below you will find a much more detailed video about sensors. After all the lamps and sensors have been made, they are now inserted into the playfield one by one. First, check whether the lamp or sensor fits completely into the hole. In some cases, they have to be lightly hammered in. Because the lamps and sensors are printed with the top side down, the edge created by the first 3D printing layer must be sanded off in most cases. Once it has been determined that everything fits, the lamp or sensor is inserted with glue. Use your finger to check whether it is inserted as evenly as possible with the playfield. If necessary, a readjustment is made. This step is repeated again and again until all sensors and lamps have been installed. In order to show the entire production process in this video, an extreme time lapse may be used. Here the first sensor is inserted into the playfield. In contrast to the lamps, I have made the first two print layers smaller in the 3D design. Therefore, no deburring is necessary for these. This would probably not be possible anyway, as the enamel wire of the coil would be damaged. After the sensor is installed, the impedance of the coil is measured to determine whether it has been damaged during installation. There was a problem with milling this sensor hole. The hole is too big. To ensure that the sensor stays in the hole and the glue can take effect, I fixed the sensor with a toothpick. Of course, adjusting the sensor is now more difficult. This sensor does not fit completely into the intended hole because the rotating frame partially blocks it. Therefore, the sensor is made smaller at the corresponding point, but this does not affect its function. Finally, all lamps and sensors are in place and the next step can be carried out. To remove glue residue, the top is sanded with 80 grit sandpaper. The sanding dust is then removed with a damp cloth. Now the lamps and sensors are glued to the underside of the playfield. To do this, I first check that the LEDs are working. If they are okay, then glue is applied to the corresponding grooves of the lamp and sensor bodies. If an LED doesn't work, the lamp or sensor can still be easily replaced. This becomes much more difficult after gluing. Here you can see the grooves on the lamp bodies where the glue is applied. The grooves allow the glue to seep between the body and the playfield. Now that all lamps and sensors have been glued, the playfield can be painted. I use polyurethane paint for painting. The painting is obviously to protect the playfield, but in this step it's mainly to make the playfield as flat as possible. Some lamps and sensors are a little too deep in the hole, others a little too high. The alternating painting and sanding should even this out. This is what the freshly painted playfield looks like. And this is what it looks like when the paint has dried. Although it looks pretty good, there are still some differences in height that need to be fixed. The height differences are clearly visible here. Where there are grinding marks on the lamps and sensors, the playfield is at the same height as the lamp or sensor. Where there are no grinding marks, they are too deep. This needs to be filled with clear varnish. To prevent the playfield from warping due to changing humidity, both sides must always be painted. To obtain a good finish, it is important to regularly remove impurities from the sandpaper. Here I use a steel ball to determine height differences. If the ball is quickly pulled over a lamp or sensor, you can hear a height difference quite clearly. Where necessary, I apply a thick layer of paint to compensate for the height difference. I'm finished with the painting for now. In a later step the playfield will be painted again. In the next video the playfield will start to be assembled. Don't miss it. Thanks for watching.